They called it the future, then they called it a mistake, and finally, they erased it.I in the middle of the 20th century, when diesel was king and steam was dying. A monster was unleashed on American railroads. It didn't burn coal. It didn't rely on pistons. It screamed like a jet. A gas turbine train, powerful, fast, and uncontrollable by the rules of its time. It was supposed to save railroads. Instead, railroads tried to bury it. This is the shocking truth behind the gas turbine locomotive, the train. That ran too hot, too fast, and too free for the system to survive. By the late 1940s, American railroads were in crisis. Steam locomotives were expensive, labor-heavy, and obsolete. Diesel-electric engines promised efficiency, but they were conservative. Safe. Predictable. Railroad executives wanted control, not revolution, but engineers wanted power, and power came from the sky. During World War II, the gas turbine had proven itself in jet aircraft, light, compact, brutally powerful. Someone asked the forbidden question, what if we put a jet engine on a train? In 1948, General Electric and Union Pacific shook hands on an experiment that terrified the industry. The gas turbine electric locomotive, GTL. Instead of pistons pushing rods, a turbine spun at thousands of RPM, driving a generator that fed electric traction motors. On paper, it was insane. On the rails, it was unstoppable. Early prototypes pushed 4,500 horsepower. Later versions exceeded 8,500 horsepower, dwarfing diesel rivals. 1 GTL could replace 3 diesel locomotives. Union Pacific. This meant fewer crews, fewer engines, and absolute dominance across the American West. Everyone else, it was a nightmare. When the turbine train moved, it didn't rumble. It screamed. A high-pitched jet howl echoed across deserts and towns, a sound so alien people thought a plane was crashing. Trackside workers complained, residents panicked, regulators took notes. The turbine didn't idle quietly like a diesel. It ran hot. Always. Fuel consumption at low speed was catastrophic, but at full throttle, it was a god. The GTL revealed an uncomfortable truth. American rail infrastructure was never designed for this level of power. Rails flexed, ballast scattered, curves became dangerous. The turbine exposed weaknesses the industry didn't want to fix because fixing them would cost billions. Instead of upgrading the system, they blamed the machine. Here's the part railroads never advertised. The gas turbine burned bunker C, the thick, sludge-like fuel left over from oil refining. It was dirt cheap. Diesels couldn't use it. Steam was dying. The turbine thrived on it. But bunker C came with a curse: ash, carbon, corrosion. The turbines clogged, blades eroded, maintenance became hell. Railroads knew the fuel was destroying the engine. They used it anyway. Publicly, the industry claimed turbines were unreliable. Privately, they refused to maintain them properly. Turbines required aircraft-level precision. Railroads treated them like steam engines. Filters were neglected, inspections rushed, crews untrained, failures skyrocketed, and management smiled, because now they had proof. The gas turbine train didn't just threaten diesel. It threatened jobs. 1 turbine could replace multiple locomotives, fewer engineers, fewer mechanics, fewer unions. Labor organizations pushed back hard. So did diesel manufacturers. So did politicians whose districts depended on diesel plants. The turbine wasn't just an engine. It was an enemy. By the early 1960s, the narrative was set: too loud, too dirty, too expensive, too dangerous. No mention of infrastructure neglect. No mention of fuel sabotage. No mention of political pressure. Union Pacific stood alone, and even they were losing patience. In 1969, Union Pacific pulled the plug, not because the turbines failed, but because oil prices rose. Bunker C wasn't cheap anymore. The advantage vanished overnight. Without cheap fuel, the turbine lost its shield and the industry finished it off. Most gas turbine locomotives were scrapped, cut apart, sold for metal, wiped from memory. No museum campaigns. No preservation efforts, just silence. The industry moved on. Diesel won. Here's the irony: modern high-speed trains, hybrid electric propulsion, aviation-grade turbines, They all echo the GTEL's core ideas. The gas turbine train wasn't a failure. It was early, too early for cheap materials, too early for emissions control, too early for an industry addicted to control. The gas turbine train wasn't buried because it didn't work. It was buried because it worked too well. It exposed weak tracks, outdated economics. Fear-based management. So they killed the messenger somewhere in the American West. Old railroad workers still remember the sound. A jet scream on steel rails. A future that came too soon, and a machine the railroads tried to bury, but never truly killed. The gas turbine train disappeared from American rails, scrapped, erased, declared a failure, but technology doesn't die when it's buried. It waits decades later. Something strange happened. High-speed trains began to rise across Europe and Asia, quiet, smooth, impossibly fast, and buried deep inside their DNA was the same idea railroads once rejected. The gas turbine locomotive was built around brute force. Thousands of horsepower unleashed almost instantly, minimal compromise, maximum output. A modern high-speed rail takes the opposite approach, not raw power, but controlled acceleration. Electric motors distribute torque evenly. Computer systems regulate traction. Energy flows with precision. The turbine shouted. High-speed rail whispers. But here's the truth. Both chase the same enemy: rolling resistance, wait time. The turbine tried to overpower physics. Modern rail tries to negotiate with it. The gas turbine's greatest strength was also its greatest weakness. It loved speed, hated inefficiency. It cruising velocity. Turbines were magnificent. At low speed, they bled fuel. Railroads run on stops, terminals, yards, switching. High-speed rail solved this by eliminating the problem: fewer stops, dedicated lines. Purpose-built corridors. The turbine was forced into a world it wasn't designed for. High-speed rail redesigned the world instead. Gas turbine trains didn't fail mechanically, they failed politically. Because their existence exposed a lie: American rail infrastructure was outdated. Rails flexed, ballast scattered, curves betrayed speed. To save the turbine, railroads would have had to rebuild everything. Modern high-speed rail did exactly that. New track geometry, concrete sleepers, perfect alignment. The turbine asked, "Why is the system so weak?" High-speed rail answered, "Then we will build a new one." The turbine screamed: jet exhaust, thermal distortion, acoustic violence. In the 1950s, this was unacceptable. Today, high-speed rail still fights the same war: noise barriers, aerodynamic noses. Sound-absorbing tunnels. The difference: modern rail learned to hide its power. The turbine never tried. It announced itself and scared the people who controlled the rails. The turbine burned fuel, dirty fuel, cheap fuel that corrupted its own machinery. A modern high-speed rail consumes electrons. Electricity can be sourced anywhere, regulated, cleaned, hidden. But here's the uncomfortable truth. If clean, cheap electricity had existed in the 1950s, the turbine might have survived. The engine wasn't wrong. Gas turbines demand aircraft discipline, precision, clean air, constant inspection. Railroads offered steam-era habits: heavy tools, rush checks, minimal tolerance. Modern high-speed rail adopted aviation culture, digital diagnostics, predictive maintenance, failure prevention instead of reaction. The turbine was judged by standards it never agreed to. Here's the part nobody likes to admit: the United States didn't abandon turbine trains because they failed. It abandoned speed itself. Highways expanded, air travel exploded, rail became freight first. Europe and Asia made a different choice. They doubled down on rail and speed followed. The turbine belonged to a future America chose not to pursue. Modern high-speed rail systems now use turbine-derived materials, aerospace aerodynamics, jet age engineering philosophy. Everything except the turbine itself. The soul survived. The engine didn't imagine this: clean fuel or hydrogen, composite turbine blades, computer-controlled airflow, dedicated high-speed corridors. Suddenly, the gas turbine train doesn't look insane. It looks inevitable. Gas turbine trains and modern high-speed rail are not enemies. They are the same idea, separated by time, politics, and fear. One tried to force change. The other waited until the world was ready. The turbine was not wrong. It was early, and history punished it for that. Railroads once believed there was a limit. A point where steel wheels could no longer touch steel rails. A speed where vibration became violence, where control dissolved into chaos. But for a brief, dangerous moment, engineers didn't care. They weren't trying to make trains faster, they were trying to make them unstoppable. This is the story of the train that came closer than anyone admits, though breaking the sound barrier. And why the world decided it should never happen again. After World War II, speed meant dominance. Jets conquered the sky, rockets chased space, highways erased distance, railroads felt humiliated. They were still dragging steel at 60 miles per hour while airplanes crossed continents. So engineers asked a forbidden question: what if friction no longer mattered? Not incremental speed, not improvement, but a jump. Steel wheels had limits: heat, vibration, harmonic instability. At extreme speed, rails didn't guide trains anymore, they fought them. So engineers explored something radical: remove contact, hover, magnetic levitation, air cushions. Jet assisted thrust. No friction. No mercy, only speed. In the 1960s, the United States crossed a line. They mounted jet engines on rail vehicles, not metaphorically, literally. The M for 97 Black Beetle. A bird rail diesel car with 2 jet engines ripped from military aircraft. It wasn't elegant. It was violent. In 1966. It hit 183 miles per hour. On conventional railroad tracks. No maglev. No dedicated line. No forgiveness. The rails screamed. The train survived, barely. Officially, the run was called a test. Unofficially, it was a warning. At those speeds, our signal systems failed, braking distance became absurd, minor track flaws became lethal. The train didn't derail, but it proved something worse: the system wasn't ready, and fixing the system would cost more than killing the idea. While America hesitated, others accelerated. France chased the TGV record, Japan refined the Shinkansen, Germany perfected stability. Each test edged closer to the edge. 300 km h, 350 km h, 500 km h. On test tracks, aerodynamics began to matter more than horsepower. Shock waves formed around noses, pressure tunnels shattered windows. Trains weren't rolling anymore, they were cutting through air. Here's what most people don't know: you don't need to hit Mach 1 to feel the sound barrier. As trains approached transonic airflow regimes, pressure waves built up, vibrations amplified, structural fatigue accelerated. At extreme speed, air became a solid enemy. Engineers realized, breaking the sound barrier on rails wouldn't just be loud. It would be catastrophic. Supersonic trains weren't impossible, they were uncontrollable. Sonic booms near cities, track deformation, emergency braking that defied physics. And one more problem no one liked to say out loud. At that speed, trains stopped being trains, they became missiles, and railroads were never built to launch missiles. The speed dream didn't die. It migrated into wind tunnel research, maglev development, aerospace-grade aerodynamics, hyperloop concepts. Every modern extreme-speed transport project carries the DNA of those forbidden rail experiments. The almost supersonic train failed publicly, but it succeeded scientifically. Imagine fully enclosed vacuum tunnels, active stabilization, AI, composite structures, magnetic levitation. Suddenly, the impossible becomes practical, not on open rails, not near cities, but in controlled corridors. The question is no longer can we. It should we. Speed has never been about transportation. It's about power, control over distance, time, people. The almost supersonic train threatened to outrun regulation, infrastructure, and fear itself. So it was slowed, not by physics. By choice. Somewhere between steel and air, between sound and silence, there is a speed we have touched but never crossed. The rails remember, and one day, someone will try again.